Nah. Come on in, folks. Settle down. Grab a seat. Awesome. Yeah, that's what I like to hear. That's what I like to hear. Good student. That's a good student. Good job. Good job. Yeah, yeah, understandable. Understandable. Yeah, there's a commitment. Going to class. Going to class. Yeah, great commitment. Awesome. Awesome. Whew. That's it. That's right, folks. Trickle in. Uh, wakey, wakey. Time for school. 13 people. Oh my god. Crow is teacher's pet? Good job, Crow. Good job, Crow. Wow. Insane. All right, folks. Welcome back to school. We're back to school. Top 2. We're in the thick of it. We're in the partial fraction decomposition part of trig integration techniques. So class, let me just say this explicitly. Oh wait, I think, hold on. Oh no. That's right. Okay, so just breaking news. Sources tell me, multiple sources tell me, all anonymous, that there's an exam on Monday, and it's trig substitution technique plus any older technique, fair game. Okay? And so that exam will be live on Canvas. Usual time, 1 to 8. It's going to be available. So no excuses. Yeah. Okay. That's what the multiple sources have told me. Okay. All right. B-boy, you missed a humongously awesome, perfectly executed lecture. But outside of that, you didn't miss much. So go watch it on YouTube. It's probably trending #1 video on YouTube right now. So you should be able to find it, B-boy. Okay. Now, yes, very funny, Kappa. That's a funny joke you just wrote down with your fingers. Okay, so let's see. Partial fraction decomposition. Let's go. Okay, but I need to hear from my students. So, if you're the smartest student in the class, go into general. Okay, look, there's only 13 of you here, so probably you are the smartest ones because the other ones are lazy. So go into general in the Discord, and I want to ask you a question. And only answer if you're just brilliant, 100% genius, okay? I don't want to hear from anyone else. Okay, let's do this. Ready? I'm going to go in there and ask you a question. Okay, let's do this. All right, folks. What is the overall strategy in the partial fraction decomposition unit? What is our overall simple words strategy for dealing with an integral of a fraction of two polynomials? Go. I want to hear it from you.
Break the fraction apart into simpler fractions.
Break the fraction into simpler fractions. 100%. I believe that was Macaco. So, awesome job, Macaco. Wait. Okay. I think it was Macaco. Good job, Macaco. Everyone congratulate Macaco. Okay, good. I heard from my class. I'll hear from you again later in the class. Okay, so generals, you can get out for now. You can go back to playing whatever video game you were playing. I know some of you were playing, so see ya. Okay, partial fraction decomposition. I want to talk about 3 things today. The angle of the camera. Okay, 3 things. Now you can see all 3 fingers. So, first thing. The case of distinct linear factors. That's the first example I'm going to show you. Oh, hi Gath. Welcome. Gath is wonderful. Go check out Gath. Second case. The case of repeated linear factors. If you're confused, you can read along here on the page. Let me unlock my iPad real fast. I'm reading these phrases. Okay? Second example, the case of repeated linear factors. Third example I'll show you today. What if there is an irreducible quadratic factor? What to do? Okay? What the hell am I saying? You'll learn through experience when you follow me down this path. Okay? And I'll write a memorandum, a secret one, sometime during the lecture. We'll draw up a secret CIA memorandum only for my class, not for anyone else. All right, everyone get ready? Okay, here we go. Here are the 3 examples that I wish to explore. Wow, how do you do that? Okay? How do you do that other one? Doesn't look like a simple substitution to me. Not directly arctany or ln. Only my students know what that means. What about this last one? That's very dangerous. That looks like garbage. That's a complete garbage can of a problem. This is a garbage can. Okay? But we'll learn how to deal with it. And I'm going to illustrate the differences between these 3 cases. These 3 cases illustrate the 3 different situations that you might face out in the world. Okay. Okay, let's dive into the first one. First one. This integral is actually in the first dream-like situation. This is the dream. This is dream situation. Okay? So here's how you deal with the dream situation. Look at it, and first filter it through all your techniques that you can think of. Does it perfectly fit into substitution? No. It's got that additive 8 really screws things over. I mean, geez, that sucks. Oh, is it arctany? No, it doesn't look like it. Blah, 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 blah. Okay, so how do we deal with it? I'm gonna deal with it now. Okay, so let me do something called copy and paste. Okay, actually, class, do you want me to copy and paste this, or do you want me to physically drag it so that you can see it? Like, are you more of a visual person? You want to see physical dragging or copy and paste? Tell me, chat. Copy. Okay, copy. Good. Paste. Okay, one person dragged. Oh, it's getting into copy paste. Okay, two out of 3. Copy paste. All right, copy this. And I'm gonna paste it. This is for B-Boy and Rack and Shrek. Boom. Did it. Done. Okay. How to deal with this? Step 1. Write this down. Factor that denominator as much as you can. Factor that bottom part. All the way. Until you can't factor anymore. Now, conveniently, I've chosen some numbers so that it becomes easy to factor this bottom thing. Unless, I mean, it's been several centuries since I went to elementary school, so I might make an arithmetic mistake here, and that's the worst part. Okay, look at this thing. Incredible. I believe. I hope this is how it factors. Okay, Kappa, that's fantastic. Fantastic. All right, so we're gonna factor this thing. That's right, B-Boy. Same with me. Same with me. All right, so there you go. It doesn't crumble any more than that, folks. Now I'm gonna observe. The point is to observe that we have two distinct class is a fancy word for different looking. Different linear factors. They each only have power of x 1. You know, like y equals mx plus b. Okay, this is great news. Whenever you see this, you are full of joy. The second thing to notice, I'm going to stick this in here. Make sure that the top part of the fraction has smaller degree than the bottom. Now, if it doesn't, long divide. If not, just do a quick long division. Division with remainder, put the remainder over x squared plus 7x plus 10, and only focus on the small remainder fraction. I did an example of this last time. We'll do another example with this complication on Monday. Remember, your homework on this material is due on Wednesday, so we'll have 2 more days of practicing. Don't worry. So I made it so that we don't have that little extra wrinkle. No wrinkle. Fantastic. Okay, so now actually the next step. Next step, step 3. Step 3 is the partial fraction decomposition step. Step 3. By the glorious miracle of partial fraction decomposition in the case of distinct linear factors, PFD DLF. By the glorious miracle of PFD DLF, which I cannot explain to you because we have no time, because of the terrible 45-minute what the hell do I do? By the glorious miracle of PFD DLF, this fraction crumbles. Crumbles in the form a number divided by the first factor plus another number divided by the second factor. It crumbles into this in a unique way. Uniquely. There are two unique numbers, A and B. There's only one way to write this kind of crumbling, where A and B are numbers. Okay, that's the glorious miracle of PFD DLF. Just rolls off the tongue. So we're going to figure out A and B. Figure out A and B. That's step 3. Step 3 is you recite this. Okay? So now I'm going to write this out. Apparently, x plus 8 divided by miracle. Incredible. All right. Okay. So how do you figure out A and B? How to figure it out? Cross multiply and follow nose. Okay, here are the steps for figuring out A and B. To figure out A and B, clear out the denominator and follow your nose. So I'm going to show you how nose following looks like. Don't worry, you'll get a sense of, you'll get a feel for it. Yeah. How do I clear out the denominator? Multiply by this enormous product. Or as my students like to say, times both sides with this. Just times it. Okay? What will you get? What would you get? You'd get x plus 8 equals. Now you just times it. And you would get times plus the FOIL it. FOIL and times. You'll get this. And now we're trying to find two numbers A and B which make this algebra problem true. Remember the goal. Find A and B which make this algebra problem true. Good? All right. Let's see what's going on. Oh, Professor. Yeah, equals the two together, then times both sides. Thank you, Professor Peter. Professor Peter, did my voice just crack? Okay. Okay, Professor Peter is great luminary. Can explain things really, really well. So, class, ask Professor Peter while I'm focusing here. All your questions. Okay. So here we go. How can I do, now here's a little trick. Tricky trick. Write this down. Tricky trick. If left-hand side is right-hand side, then it's true for all x's. So in particular, if I very carefully plug in some particular x values, I can get somewhere. Tricky trick. Plug in funny x values. Which ones? X equals -5. Plug this in. Both sides. On the left hand side, I will get something. -5 plus 8 equals a times 0. That's funny. That's why I did it. That's what makes it funny, folks. It's great. Plus b times -5 plus 2. Okay, now look at this. It's really funny. 3 equals b times -3. I think I did that right. So then b is -1. Wow. We are halfway there, folks. Our goal was to figure out these two miraculous numbers, and we found one of them. That's a great thing that happened. Okay? Okay, you can do another one. You can play this. You can do more funny. More funny. That's a funny one. That's a funny number you can plug in. Look, because look what happens. Zero. Okay, and then look what happens. Look at this. Carefully. Everyone write this down. You guys seeing this? You guys see? Step 8. Where are we? Step 8? Step 8. Put it together. Put it all together. So, bring that down over here. X plus 8, blah, 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 blah. This complicated fraction is a, which one was it? X plus 2. Good. Make sure you pair them with the right ones. Plus b what was b over? X plus 5. Correct. Wow. That's Pog. Why is it Pog? Because as one of the greatest students in the class, whose name is Macaco, had told us earlier, the whole point is to crumble the complicated fraction into the sum of two simpler fractions. And now look, the integration, but folks, we haven't integrated yet. Always keep in mind, have I integrated yet? No? Then you should integrate. Yes? Then don't integrate again. Those are two life lessons. Okay, so here we go. Now I have to do the problem. Trade. Be a trader. Be a trader. And class, how do these two integrals look? How do you feel about these two separate integrals? Eleni! Right. They are Eleni. Eleni, macaco, right. Awesome. Absolutely. So you just immediately, boom, boom. 2 times ln, boom, minus ln, boom, plus c. Boom, done. So we actually could integrate that thing, it turns out, with the magic of PFD DLF. That's the case when you have when the bottom factors into some number of distinct linear factors. That's the situation. You can crumble them with this template. A number over one factor plus a number over a second factor. So now I'll tell you the general story. More generally. If you have the situation with 3 factors in the bottom, a fraction with 3 factors in the bottom now, with distinct, different, and if the numerator is smaller than the degree of the bottom, so it's like a proper fraction, you don't have to do division with remainder in order to make it smaller. So also, if this is smaller degree than bottom, which in my example, which is a bottom has now degree 3, because you'll get an x times an x times an x. X cubed will be the highest term on the bottom. Suppose we had a problem that looked like this. P of x is a polynomial with degrees smaller than 3. Polynomial means only positive powers of x and numbers. No 1/2 power, no negative powers of x. No, bad. Okay? If you have this kind of a fraction, the miracle of PFD DLF still says that you can crumble this into 3 factions. 3 factions. Never admit mistakes, folks. I intended to say the word faction. All right? That's confusing. These are just 3 numbers. And the A's, the capital A, B, C, have nothing to do with those 3 numbers. That's confusing. Let me go change this to, I'm not going to change it. That's a lowercase c, and that's a capital C. You can trade this off for 3 numbers, A, B, and C. And then just have to tease out A, B, and C. And how do you do that? You follow your nose. Clear denominators plus follow nose. Yeah, plug in some funny things. Like plug some funny things in. For example. Okay? Awesome. And what if you had 4 different linear factors in the bottom and a polynomial above it whose degree was less than 4? Can you crumble that? With 4 sums? Yes. The miracle persists as long as you're looking at distinct linear factors. Awesome. This is amazing. Okay, so next, I'm going to move on to the next troll example. How this is easy. Distinct linear factors. Done. PFD. How to do this one? How? Uh-oh. The bottom is 1 linear factor times itself. Wow. How to deal with this? Copy and paste. The class enjoys copy paste. I'm going to copy this. And we're going to go deal with that, class. It's going to be fun. Wow, I copied a lot. I copied the circle too. Okay, here we go. How? I'm going to execute the steps in this case. And notice there will be a little bit of an extra pepper at one point. Okay, step 1. What would I call step 1? I make them up. I make up the step. Okay, what would a step be? Oh, factor the bottom. Yeah, factor the bottom. The bottom. Oh! It's already factored. Already factored. That's funny. That's funny. Okay, factor the bottom. X minus 1 times x minus 1. Step 2. Step 2. Or check. You know, step 2, just a little check. Check. Make sure the top is smaller than the bottom. Smaller degree. Oh, good. Phew. Okay. If it wasn't, we'd have to do a little bit of long division. Bottom into the top, collect the remainder. I'll do that on Monday. Forget about it. Okay, step 3. Step 3. This is the partial fraction decomposition step. Okay, straight from Chegg. Yeah, I was educated by Chegg, 100%. Chegg definitely taught me everything I know. I would just like, the first moment I couldn't do a problem, I would just Chegg it. And that's why I know how to do these problems so fluently. Because I just immediately was gratified with the solution. And so that gratification just makes me stronger. Yeah, that's how that works. Step 3. Ready? Partial fraction decomposition in the presence of a repeated linear factor. In presence of repeated linear factor. So if you need, so in your note cards, write down PFDIPORLF. PFDIPORLF. What this this theorem tells you, it's a miracle. Miracle of. Yeah, sorry, write that, add that in the note card. Miracle of partial fraction decomposition in the presence of a repeated linear factor. Okay. This fraction can be traded off for a particular unique expression of the following form. Don't square. Just put that linear factor in the denominator and stick a, there's a number that you can stick above it, but that's not it. You're gonna have to have some more flexibility, and you have to allow yourself to use these kinds of simpler fractions as well. So by the partial fraction decomposition repeated factor version, there is some magical way to crumble this fraction into a number over x minus 1 plus a number over x minus 1 squared. That's right, Just a Human Guy. That's right. Everyone's getting it. That's right. Awesome. Okay. So, that, what we're saying, this amazing result tells us that it's possible. But then you gotta go find those two numbers. You gotta find the two numbers. So now, let me put the OG fraction here. 2x minus 3 over x minus 1 squared. Class, if you've lost the thread, remember, what did Macaco tell us? The idea is to crumble a bad fraction into two simpler fractions. That's all we're doing. We're doing it in different situations. They have different flavors, slightly. Okay. They have different templates. That's a word. Okay. So how to do this? So now we gotta just follow our nose. Follow the nose. Follow your nose. Step 5. Follow your nose to figure out A and B. Okay, let's see if we can do this. Okay. Here we go. Clear the denominators out of there, folks. That's just garbage. Clear that out. Clear the denominator. So times both sides. Get rid of garbage. Okay, so you multiply by this thing, both sides. Okay, so left side will be 2x minus 3. We're in the silver zone now, or whatever this color is. And then the right side, FOIL and times combined. Yeah, you get A times, there's still a little bit of x minus 1 left when you multiply by x minus 1 squared. But then the B is just by itself. B is just by itself. And then, yeah, okay, good. And now, you're trying, remember the goal. The goal is you're trying your darndest to make this left-hand side equal to the right-hand side. Goal is, don't lose sight of the goal. That's what I mean by follow the nose. The goal should be right at the tip of your nose right here. Always keep the goal in your vision. The goal is to make this a true fact in algebra. Make this a true fact. Find A and B that make it a true fact. Okay. There are many ways to go. There's not some one way. Just whatever comes to you is good. Here's a trick that can help you. A helpful trick. Tricky trick. Tricky trick. What was the name of this trick? How do you do this, folks in chat? What do you do for a tricky trick? It can get you places. Oh, what do you do for a tricky trick? Nobody knows. Funny plug-in. Funny plug-in. Plug-in funny numbers. Good. Macaco, good. Very good. Plug in funny x's. In this case, x equals 1 looks rather funny. Plug that in. 2 times 1 minus 3 equals A times... plus B. Okay? Got it? Okay, this is gone. And you end up with negative 1 equals B. Wow, pretty good. Not bad. Okay? Not bad. But not good either. This is 50%. This is a solid F. So far, we have earned a solid F. Solid F. Oh, there's an A. We gotta find A. All right? So notice that we don't have another funny X to plug in. You notice the tricky trick is a little bit deficient here. Yeah, Crow. Crow sees that there seems to be a problem here. The tricky trick has run out of its juice. Don't worry. Just plug in what you know at this point and then keep following your nose. Just plug this in though. Plug it in. Plug this in. And follow nose. Okay, plug this in here. Okay. So we get 2x minus 3 equals a times x minus 1 plus negative 1. Okay? And now just FOIL out the right-hand side. This equal sign is, we want this. We want the left-hand side to be the right-hand side as algebra exercises. Okay? Yeah, you can plug in any x. You can plug in, yeah, that's another way to go, by the way. You can just plug in x equals 500 on both sides and solve for a. B-boy, good job. Plug in x equals 500, or maybe like 0, maybe 0. That could help. You don't have to do 500. You can try to do an easier one. Yeah, plug in x equals 0. Let's do it your way, B-boy. Let's do it your way. I was gonna follow a different nose, but your nose is good. So plug in, try x equals 0 on both sides. Yeah? Okay. Oh, look at that. Minus 3 equals a times 0. That's good. That's a good one, B-boy. That's good. Oh no, my screen froze. Hold on, folks.
What is he doing?
He's beginning to believe.
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 What is he doing?
He's beginning.
What is he doing?
He's beginning to believe.
Oh no.
What is he doing?
Oh no.
He's beginning to believe.
Too much magic.
What is he doing?
He's beginning to believe.
What is he doing?
Okay. Ah, good. Good. Okay, we're back. Oh my god. I'm glad you all were starting to believe. Your belief helped me through that. Your belief in me helped me. Okay, let's go. Let's go. I can slide the screen again. Negative a equals. Wow, that took up like 10 minutes out of my 45-minute. Thank you, OSU. Okay, negative 2. So a is 2. A is 2. Done. Thank you, B-boy. Got us through there. And whatever physics was involved in getting us through that sliding disaster, thank you, physics. Okay, put it all to, oh, step 8, right? Step 8? Let's not lose sight of where we were. Step 8. Class, in unison, what is step 8? Let's let 15 minutes go by because of delay and classes asleep. But let's see. What do we do with this garbage? This pile of garbage that we just figured out. What do we do with it? No. What do we do with the garbage A equals 2 and B equals whatever, net minus 1? Put it all together. Trade, Math Mama. 100%. Math Mama, good job. Trade it in. Be a trader. Be traders. Be a trader. Be a trader. Math Mama and B-Boy on point. Everyone else, just robotically screaming, Eleni! Okay. Alright, here we go. Put it all together. 2x minus 3 is trade. A, put it in the right spots. A over x minus 1. Plus, negative 1 over x minus 1 all squared. Interesting development. So, original integral is this integral minus, this minus is here. Okay, so now I have to just share with you that we're in good shape here. Oh my god, thank you everybody who followed. Okay, there's only 3 of you. Never mind. Okay, so all right, here we go. So first integral, Eleni. Boom. Eleni. What is Eleni really? It's substitution. That's what it actually is. I want to tell you this now that you've grown up and it's been some time. You know, not everything's just a bunch of jingles. This is just substitution. Substitute. And that's why the other integral is also friendly. Also substitution. U equals x minus 1. Then you would get u to the minus 2 du. Notice that the du is dx. So there's no extra sauce in the translation of dx. So you get this integral. This is anti-power rule. Anti-power rule. Okay, and you get negative 1 over u. Just for this. I haven't introduced the other minus sign yet. I have done negative u to the minus 1. Minus u to the minus 1. That's what you'd get if you do the anti-power rule. And if you're young and don't make mistakes, not like me, I will make mistakes all the time at this point. Okay, so this is negative 1 over x minus 1. Okay, and then there's this red dangerous minus sign. So you get positive 1 over x minus 1. And you stick that here. Plus c. Boom, powered through. Tackled. Done. Awesome. What to do in the presence of a repeated linear factor? You give yourself as many repetitions as you need, as are there. Notice we stopped at 2 because the repetition amount was a 2. So let me now summarize how to crumble in the presence of a repeated linear factor. And then it's 12:15. Out of the 45 minutes, I got the 2 out of 3. Don't worry, we're in luck. We have all of Monday and Wednesday to sort of get through all the different situations you might face in a fraction. So here we go. Miracle of partial fraction decomposition in the presence of repeated linear factors. Okay? Just a little catchphrase. Okay. If you've got a polynomial divided by x minus 3 to the 14th power, and as long as it's a good proper fraction, go do long division until you carve out the proper fraction part. More on that Monday. Okay. As long as this is degree less than 14. Like x to the 5th minus 3x plus 49.2. Whatever. I don't care. Okay? That can be crumbled. Please remember the initial answer that the great student Macaco gave us. The goal is to crumble a fraction into friendlier fractions. And what this miracle tells us, there's a miracle that says you can take this kind of a fraction and trade it for a over just x minus 3. Plus, you gotta give yourself freedom to sprinkle in a little bit of x minus 3 squareds. But b is just a number. Plus, another number times x minus 3 cubed. Plus, another number. Give yourself the freedom of another number. Plus, give yourself a little bit more freedom. You're gonna need it sometimes. Depends on what the p of x on the top looks like, but sometimes you just have to have, you gotta have a little bit of these fractions available to crumble, okay? To be a building block. And plus, you do that. You gotta have a little bit, that much too. Okay, then okay, you gotta. It's not. It wasn't just enough to have the 6. You could have. You gotta give the person some flexibility, with a number divided by x minus 3 to the 7th, and then I trust my students have understood the pattern. What's the letter? E F E H I J A L M O. Did I get that? Algebraically challenged, trusted person. Oh, definitely. Oh my god, that's sad. That is sad. Okay, class, do not get confused. This is not a 0. That's not a 0. Okay, you know what? That's gonna confuse my class. I'm gonna change this 14 to a 15. 15. What if it was 15? No. P. Perfect. Oh, but that's not the same P. That's not the same P. 16. Element of P, Q. There we go, Q. Over x minus 3 to the 16th power. Okay? There's the fact of life is you can trade this off. And why would you want to trade this off? Why would you want to trade this off? Because each of the integration problems on the right-hand side are just straight up substitutions. Each of these is just straight substitution. Straight Chizonin style substitution. Is Chizonin here today? He was playing games yesterday, last time, so. Hot Tamale is playing Evading Taxes. What kind of video game is that? Okay. But Chizonin's probably asleep by now, so. Yeah, looks like they're asleep. Okay? Alright. Okay. I'm not sure what people are saying now. Okay, so just straight up, substitution would kill all of these right-hand sides, and that's why it's a profitable trade. All right, so on Monday, we will deal with the third scenario here. This is a new type of situation. This situation is new because if you look at the bottom cannot be factored anymore at the burp. Now, x squared plus 1 can't factor it because look, it doesn't have any solutions in the real numbers. So that's a situation where you've got a irreducible quadratic factor. Okay? And you've got 1. Meaning that factor didn't happen twice. Like it wasn't x plus 1 all squared. That situation is even later. Okay? So now we've got this funny puzzle. What if you can't factor it all the way into linears? How the hell are you supposed to go from there? Stay tuned on Monday. Okay, so that's enough for today. Let's see what's going on. Yeah, there was no respect today. No respect. For me, for anybody. It was all just rude. Okay? Yeah, no respect. Alright, let's see. Let me go look at the chat real fast, okay? Let's see what happened here. After the Greek. Not sure. What then? Got some people who saying some bad words. That's not cool. Alright. Luckily, nothing shows up. So that's funny. Draw a line through it so we know. You want me to... Oh! That's interesting. So you were... I think that was... B-Boy was saying, instead of writing O, you can draw a line through it like this. And make it like... What is that, Norwegian or something? Like... Is that Norwegian? I don't know what language that is. I'm not sure. Yeah, oh, but we actually... I'm trained not to do this because yeah, that has a meaning in math, and we just don't do that kind of thing. But yeah, that's an interesting idea. I dealt with it the way I dealt with it. All right, B-Boy. So yeah, don't criticize me. This is not on the quiz on Monday, no. But the next one, it's definitely going to be on it, B-Boy. The week after Monday. Fair game. So don't wait to learn it. Learn it. Okay. All right. I've seen people put a dot inside the O to avoid confusion. I'm not even gonna... I don't think that's a real thing, so I'm not gonna do that. And I think I suspect... Okay, very good. Go back to elementary school, Kappa. Yeah, that's good. Okay, take some respect. I have some to spare. Oh, thank you, Space-Time Explorer. Finally, someone says something good. Good, good. Oh, Juggle was redeemed? Oh, follows. Thank you, Greece. Larry Logo. Vilma. UN Simon. All of you, thank you. That's great. Welcome. Welcome to this degenerate classroom. Okay. Okay, so I got to juggle because someone redeemed it. And then we'll call it as long as people are satisfied. Okay, let's go do that now. Where are... All right, class. While I juggle to end the stream, go over the different situations we might encounter when facing a fraction with two polynomials on the top and on the bottom. And notice how we've sort of dealt with two situations. We're going to kind of expand and collect some other situations on Monday and then finally on Wednesday. But after all of that, you will see that with the power of partial fraction decomposition, we can reduce complicated big fraction integrals with integrals of much simpler looking fractions. Fractions that are arctany or ln or just straight up Chisonin style substitutey. Okay? There you go. There's your juggle for today. Alright. Oh, thank you, Raoul Thompson and Monkey and Crow. Crow did the juggle. Okay. BMP, that's you. And all I see are 3 asterisks, Crow. So there you go. I can't see what you just wrote. So that's great. Fantastic. Okay, yeah. Anonymous Cowboy. I don't know if that's a hello or a goodbye, but goodbye it is. And have a good one. Let's see. Okay, good. I've got some yeah, I don't see links. So that's Shungite. Okay, someone needs their Shungite. 0 to Hero Dev. He's feeling, or she is feeling, a Shungite withdrawal. So here you go. This is real Shungite. I have the certification. I hope I didn't vacuum it. Then no one will believe that this is real. Where did the certification go? Oh no. Is this it? Ah, yes. So, 0 to Hero. You see this pristine certificate that is ripped a little bit. This says that this is a real Shungite. So, don't go buying fake Shungite. That's just carbon or whatever. That's just a bunch of coal or rock. Get the real stuff, which is much more involved and different than just carbon. Okay? There you go. Let that defend you against all negative vibrations. Okay, let's get out of here. I believe we've exhausted all of our trolling for the day. Let's see. Who are we gonna raid, folks? Hey, Crow. You're the teacher's pet today. You redeemed it using your channel points, which don't matter at all. And, so please pass it along. Look at this meme. Please pass it along. Okay, we will do, Crow, since you are teacher's pet. We'll take a look at it later. Now, I need to drop all you kids off somewhere. Is Professor Peter on? No, just someone named Professor Broman. I'm pretty sure we shouldn't go to Professor Broman. Okay. How about Prof. Melko? Are they still on? Okay, Prof. Melko's on. Here we go. Alright, go back to Prof. Melko, alright? Everyone, I know that that's where you guys came from. You all came from... Wait, who's Erichto? Who's that? Wait. Okay, who? Tell me about Erichto, Crow. They look like a... Are they a professor? Crow? 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 You there? Did Crow just left? Great. Okay, well, whatever. We're gonna go to Prof. Melko. That's where we're gonna go. Programmer? Nah, let's go to Melko, dude. Programming, kind of boring. Okay, let's go. Prof. Melko. Let's go. Good suggestion, though. Let's go. Get out of here. Go to Melko. Go. Start this raid. Here we go, everyone. Go back to where you came from. I know this is where you came from. Go back into Professor Melko's stream. Thank you. Good day today, class. Good work. Good work. End the stream.